Hello, I am Lynn Mahalitz, the project manager.
I'm Evan Hill. I'm the technical writer.
And I'm Hayden Hammond. I'm the design engineer.
We are from Guntersville High School and will be presenting the household assistant.
So the household assistant was originally designed as part of the VEX competition. For this competition, the assistant needed to be able to maneuver tight spaces, lift heavy objects, and climb up steep inclines. As a group, we recognize the value of these constraints and the opportunities it opened as they mimic the needs of a household assistant bot.
For instance, individuals with disabilities may struggle with both lifting and transporting objects around the house. This problem is only exacerbated by the rise of Amazon, who leave packages at the front.
The household assistant is the solution. By virtue of being able to carry and transport these items, the household assistant is a valuable tool and enables one to enjoy freedoms again. The household assistant is made of VEX V5 components and is the result of months of hard work. Over the course of the project, we have designed, built, redesigned, and rebuilt many times. Thus, we learn the importance of planning and the value of 3D modeling. Here's our 3D model. While we decided only to make a partial 3D model, the purpose was to ensure proper alignment of the components, and thus only a partial model was needed. For our VEX project, we used VEX V5 components and VEX code to program. The model was made in Inventor.
Over the course of designing this robot, we used an engineering notebook in order to keep track of our design as it progressed. We began in late October and have been continuing since March. Overall, there are 19 logs in total, including a brainstorming design at the very beginning of the year in August. When we first started, our robot was essentially a box that had wheels with it. There was no internal mechanism in order to fulfill the initial components or requirements that we had sustained. We merely wanted something that was able to move with human input. As such, we have this crude beginning. There were multiple problems with this initial design, and we still needed to come up with any sort of mechanism that would be able to fulfill the original requirements that we had set out in the very beginning in accordance with our constraints. Over time, models of the forklift mechanism that would be used to lift heavier objects emerged as we continued to scrap designs in any sort of process in order to see what worked and what didn't with our current materials. Around December, you can begin to see a finalized version of the robot. Much of the gear trains and other mechanisms present within it are able to be replicated from these initial areas. The similarities between our current design and the design from in December is very high, or at the very least, they are very similar. The latest log that we had was in early March, log 19. While there was no sketch for this log, our main goals were merely just to practice and troubleshoot any sort of problems that remained with the current design.
Now let's move on to the video. Please click the next video on the link to see the fun part of the project. Thank you so much.